Hello everyone, this is Rajamanikam and Animuthu from QPT. In field tests, MIT spinoff AgZen demonstrated that its feedback optimized spraying system could halve the pesticide needs of farms and improve crop yields. AgZen has developed a system for farming that can monitor exactly how much of the sprayed chemicals adheres to the plants in real time as the sprayer drives through a field. Built-in software running on a tablet shows the operator exactly how much of each leaf has been covered by the spray. Farming can be a low-margin, high-risk business, subject to weather and climate patterns, insect population cycles, and other unpredictable factors. Farmers need to be savvy managers of the many resources they deal, and chemical fertilizers and pesticides are among their major recurring expenses. Despite the importance of these chemicals, a lack of technology that monitors and optimizes sprays has forced farmers to rely on personal experience and rules of thumb to decide how to apply these chemicals. As a result, these chemicals tend to be oversprayed, leading to their runoff into waterways and built up in the soil. That could change thanks to a new approach of feedback optimized spraying invented by AgZen, an MIT spinoff founded in 2020 by Professor Kripa Varanasi and Vishnu Jayaprakash. Over the past decade, AgZen's founders have developed products and technologies to control the interactions of droplets and sprays with plant surfaces. The Boston-based venture-backed company launched a new commercial product in 2024 and is currently piloting another related product. Field tests of both have shown the products can help farmers spray more efficiently and effectively using fewer chemicals overall. Worldwide, farms spend approximately $60 billion a year on pesticides. The researcher says that their objective is to reduce the number of pesticides sprayed and lighten the financial burden on farms without sacrificing effective pest management. While the world pesticide market is growing rapidly, a lot of pesticides sprayed don't reach their target. A significant portion bounces off the plant surfaces, lands on the ground, and becomes part of the runoff that flows to streams and rivers, often causing serious pollution. Some of these pesticides can be carried away by wind over very long distances. With support from MIT Tata Center and the Abdul Latif Jamil Water and Food Systems Lab, Varanasi and his team analyzed how droplets strike plant surfaces and explored ways to increase application efficiency. This research led them to develop a novel system of nozzles that cloak droplets with compounds that enhance the retention of droplets on the leaves, a product they called enhanced coverage. Field studies across regions from Massachusetts to California to Italy and France showed that this droplet optimization system could allow farmers to cut the amount of chemicals needed by more than half, because more of the sprayed substances would stick to the leaves. However, in trying to bring this technology to market, the researchers faced a sticky problem. Nobody knew how well pesticide sprays were adhering to the plants in the first place. So how could AgZen say that the coverage was better with its new enhanced coverage system? Agricultural spraying essentially comes down to dissolving a chemical in water and then spraying droplets onto the plants. But the interaction between a droplet and the leaf is complex. The researchers says that they were coming in with ways to optimize that, but the growers have never even really looked at that in the first place. Although farmers have been spraying agricultural chemicals on a large scale for about 80 years, they have been forced to rely on general rules of thumb and pick many interlinked parameters based on what has worked for them in the past. Before AgZen could sell farmers on the new system to improve droplet coverage, the company had to invent a way to measure precisely how much spray was adhering to plants in real time. The system they came up with, which they tested extensively on farms across the country last year, involves a unit that can be bolted onto the spraying arm of virtually any sprayer. It carries two sensor stacks, one just ahead of the sprayer nozzles and one behind. Then built-in software running on a tablet shows the operator exactly how much of each leaf has been covered by the spray. It also computes how much those droplets will spread out or evaporate, leading to a precise estimate of the final coverage. The tool was developed to prove how much AgZen's enhanced coverage nozzle system, which will be launched in 2025, improves coverage. But it turns out that monitoring and optimizing droplet coverage on leaves in real time with this system can itself yield major improvements. The company launched its first product, the coverage optimization system called Real Coverage, this year, reaching a wide variety of farms with different crops and in different climates. Once AgZen has proven the effectiveness of using coverage as a decision metric, and after the real coverage optimization system is widely in practice, the company will next roll out its second product, enhanced coverage, designed to maximize droplet adhesion. Because that system will require replacing all the nozzles on a sprayer, the researchers are doing pilots this year but will wait for a full rollout in 2025 after farmers have gained experience and confidence with their initial product. Thanks for watching this video. Now you can get my ebooks with a huge discount at www.rajamanickam.com by using the discount code QPT. Contact me if you are interested in earning a 50% commission for selling my ebooks. Thanks.